Let's do this lab assignment problem from section 8.1. This is problem number 1. They want us to find the exact length of the curve, and the curve looks like it's y squared is equal to 16 times x plus 2 quantity cubed. X goes from 0 to 2 and y is positive. Now this looks like it's an implicit function, which means if you graph it, it might not pass the vertical line test. But there's a couple of hints as to which direction we should go. They're giving us values for x, so that could constitute the limit, which means we probably will be taking the integral with respect to x. And then they're also looking at just the positive part. So if we were to take the square root of this, technically the square root would be a plus or minus square root of this quantity, 16 times x plus 2 quantity cubed. But instead of looking at the plus and minus, we can just look at the positive part because they said y is bigger than 0. It also might be good to graph this. So let's see if we can graph this. Using Desmos, you can actually graph implicit relationships. So that's y squared is equal to 16 times x plus 2 quantity cubed. And so we do have this this graph, and if we go if we let x go from 0 to 2, then we can't see it, but I think if we zoom out, we might be able to see this part right here. So this is the piece of the graph that we want on the positive side. The graph exists on the negative side, but we only want the positive side. All right. So for the given arc, for a curve given by y equals f of x, if we solve for y here by itself, the length is going to be given by 1 plus, I think this is going to be dy dx quantity squared. So let's put a dy here because that's what the formula says. Now if you're integrating with respect to y, your integral might look like dx dy instead of dy dx. Alright, so here we're going to take the square root, and it looks like they take the square root of each of these factors, and so the square root of 16 is 4. Again, y is bigger than 0, so we just need the positive part. And then now we need to take the square root of x plus 2 cubed, and I think that's just going to give us a power of 3 over 2. And so now we want to take the derivative of that because that's what the formula says. And so the derivative of this is going to be 4 times 3 over 2. So that's going to cancel the 2 and the 4, and that would give us 6 as a constant. And then we have x plus 2. And then we need to subtract 1 from 3 halves. So 3 halves minus 1 is 1 half. And that's going to be the power that we have. Technically we needed to take the derivative of the inside, but the derivative of x plus 2 is just 1, so we should have included that, but it worked out. And then the arc length formula says that this is going to be equal to 1 plus, now it's going to be this whole thing being raised to the second power. So if we were to do this on another sheet of paper, this is going to be raised to the second power. But that's more complicated than what it seems. So if we just take it by factor, this is going to be 6 squared, that's 36. And then x plus 2 raised to the 1 half squared would just eliminate the 1 half, and that's just going to be x plus 2. So let's rewrite this whole thing and write it as 36 times x plus 2. Yeah, so that's the dy dx quantity squared. So it looks like this is just a linear term under a square root, And so the best way to probably solve for this is just to do a simple u substitution. We're going to let u equal to everything inside of the square root. And then the du is going to give us a factor of 36 times dx. And so now doing the substitution from 0 to 2, when we put 0 in for x, in our u expression, 0 goes, and then that's going to give us a 73. And when we put 2 in for x, this is going to be 36 times 2 is 72, plus 73, that's 145, I believe. So now we have new limits. This is just going to be u to the 1/2, or square root of u. And that makes a fairly easy integral. So the integral of that is u to the 3/2 divided by 3/2, or times 2/3. And then we put in values for u, since we changed the limits already in terms of u. So it looks like we're going to have 1 over 36, and then we're going to multiply this times 2/3. Actually, we can put the 2/3 out. Oh, we'll just leave it here. 2/3 times u, evaluated at 145, and this is going to be raised to the 3/2 power, minus the 2/3 again times 73 raised to the 3/2 power. There's probably ways to simplify that, but let's just submit this, and then you can see the simplified version of our answer written here. That's 1 over 54 times 145 to the 3/2 power. That's like 145 times root 145. And that's the same that goes for 73 to the 3/2 power. Okay, I hope that helps.